Um, okay, so here we have, for example, we have a bundle and we have a log service. And we have here, for example, an IBM log service that implements the log service. So the top log service is only an interface definition in form of a Java interface file. And then we have another bundle or another class which implements this log service. We can have another log service. For example, we can have a Motorola log service that implements the same interface. And we can have a third one, which is just a simple log service that does nothing more than just take the log and print it to standard out. Now, the bundle only gets the log service. And depending on who registered, so there can be one or multiple service instances registered. So what happens is the bundle would talk to the framework and do a GET request on the framework. Basically get service and then specify, okay, I want the service that implements the log interface. And then it gets, in this case, for example, 3 objects back, and it can choose either to use one of them or all 3 of them, or just use the first one, whatever is convenient. But the important thing is...
Excuse me, I have a question.
Yeah?
This is like, just like any J2E specification, right? You have like an interface. Then you have different drivers, you implement register the drivers.
Yeah.
The first question is like, you mentioned about like the registry before. So this information has to be put in the registry, right?
Yes.
And then you can have more than one registry and someone who's going to control all of them and get the data, at least conceptually.
You have one registry.
One registry.
Yeah.
How are you implementing that registry? I mean, like, how is the, when I say the implementation, meaning, because there are 2 ways. One is like, if you take the web services, like they have, for example, EBXML registry, right?
Yes.
In the EBXML registry, you publish the data, all the XML files, and then you have like some sort of like a metadata. You query the metadata from that's going to go and like get actually the data and then like send the information back, just like the way you're doing the query. So how is the registry for this? Is it like a flat file kind of thing, or is it totally independent of implementation?
So the registry, it's part of the framework implementation. So it's only specified the API for the registry, like how you register and how you look up services. Typically, this is not stored in a file, because typically this is just transient data. After the framework starts up, bundles start to register and start to look up services. But as soon as the framework shuts down, there is no real need to keep the data persistent. So it's typically only stored in RAM. And the query language is LDAP based. So.
Okay. The question that guy asked before about the versioning, why can't like, because when you get the query, I'm assuming the information you're going to get back is like metadata, right? I mean, yes. Like if a query particular thing, like, when you have the metadata, like, what's the structure that's going to be, like, what are the functions it's going to support, so on and so forth, right? In such a case, when you no, at the log level, why can't you have like, when you get the object, right? I mean, if you have 2 different versions,
yeah.
You can have like, you can display to the end user like these are the 2, I mean, like 2 different versions or 2 objects existing for this particular type. Based on that thing, because I'm assuming like first time you query the registry and get like the information about the object. So you know the syntax for that object, doing the reflection or whatever. Then you can build the second time you actually invoke the call.
Yes.
So when you're doing the first time, why can't you choose what version you want, and in the second time, like for that particular object, for that particular version, why can't you move the method?
Okay, so let me explain how it works on an API level, really. Because I think it works different from what you expected with the J2EE registry. So the assumption here is that the bundle was implemented and compiled against the interface of the log service. So it doesn't need to do reflection or anything, because when you compile it against the interface, you can just do regular method calls. So you assume that you know the interface when you do a get on the service. And you get the service actually by giving either a reference to a Java interface or giving the textual string name of the interface. And then you get back an array of objects with the results. And the results you can annotate them with, as I said, when you register a string, when you register an object in the registry, you give a string with properties, and one of the properties can be, for example, a version number. So when you look up a service with a specific version number, you can specify which version you want. And if you don't look for a specific one, then you still get all the strings back. So you can, if you get more than one, you can, for example, choose to use the one with the highest version. But it's actually simpler than it is with J2EE, because you don't have to worry about not knowing the interface.
Yeah, so that's the question. Like, I mean, the method invocation you're making, whether it has to be static or it can be dynamic also. So if it is dynamic, then you can get the version number and from there, like, because when it is dynamic, you don't have to know upfront itself, like, what actually the object is. First you make the call, then, like, get the reflection, then you know the method. Right?
Yeah, well, so when you create the bundle, say you implement a bundle against the lock service, you would in your build environment, you have a version of the lock API, so you have the lock interface, and you compile everything, and then you wrap it together into a bundle. And say in the one case, you do not include all the lock API Java interfaces. So for example, you have something like OSGi.framework.log, which specifies the lock interface. You leave out this package and you package everything else together. Now if you would start this on a standard virtual machine, it wouldn't execute because it would basically give a class not found exception because it doesn't find the lock service. And that's where you would need all the introspection mechanisms. In the OSGi case, you would specify in your manifest that you need the OSGi.framework.log package. The question is, where is it coming from? So in order for this bundle to start and to not fail with a class not found exception, some other bundle must have been started before, which had this implementation, this package, and which exported this package. And in this case here, this would be the lock bundle up here. So this lock bundle would bring the implementation of the interface, or the definition of the interface. So this would contain the class file with the interface definition, and the other bundles here, like the IBM log, would contain an implementation of this interface. So you would actually, both the IBM log bundle and the client bundle would import the package exported by the log bundle. So they both have access to the class file, which defines the interface. And then when you do a lookup, you get an instance of an object which has been instantiated and registered from this bundle here and put in the registry. And then you can class cast this object to the log service class that you have imported, so the class which was part of the package that you imported from this one. I agree it's a little bit confusing, but it's actually easier when you see it in code. So, I don't know. Oh, there was another one of those funky presentation thingies. So that's what the interface definition looks like, just in case. It's public interface log. As I said earlier, different bundles can implement the same interface. We've gone through this a number of times now. The OSGi defines a standard set of services or a standard set of interfaces, and we have notification for lifecycle events, and each service has a unique ID. That's just another way to represent services. We did this in the specification and a little bit in this presentation here. Basically, each object that implements a Java interface can be registered, unregistered, or modified as a service, and other bundles can actually get the interface. And we have typically one person or one bundle registering it, and we have multiple bundles looking it up. The registry, so there is one registry, and this registry is available to all bundles, and it's here in order to collaborate with other bundles. It requires permission to register and unregister objects, checked through the Java 2 security API. And the services are annotated or associated with properties, and there is a query language available, which is very close to LDAP to find services. And bundles can update the properties as needed. Yeah, service factories is another tricky implementation way, because we have seen before, we have one object which gets registered and multiple bundles can look it up. Now if you want to have customized object for each client that looks it up, then we can use service factories and we can customize the service per bundle. There is a service factory interface, and it allows a bundle to return a customized object for each request. And the framework then calls back this factory every time for a get or unget. So in this example, there is a standard bundle which registers a framework service, and we have two bundles looking up the same service, and they both get a reference to the same service, to the same object. Now in the factory case, we have a bundle that registers a factory, and it doesn't have an actual instance of an object. Now bundle A wants to get a reference, and then the framework actually calls back into the bundle factory, which then creates one and hands out a reference. And bundle B asks for a reference. There's a callback to the factory. We create an object, and then bundle B gets a reference. So you can use this to do dynamic proxy generation, like on-the-fly code generation. And then we can manage dependencies between bundles. As soon as bundles have references to other objects, there is dependencies. And if I uninstall a bundle that another one has a dependency on, then I must notify this one. And that's the whole event mechanisms. So bundles which are installed and started will create events to other bundles to either indicate that they become available or that they're going away. So here, for example, we install a new bundle which creates events that this bundle has been installed, and interested bundles can get notified for that. Then this bundle gets started, which, for example, in this example, it gets a service and it registers service on its own, and then bundle B receives an event that bundle A has now registered a service, which can, for example, trigger bundle B to get the service. So this could be that a bundle has started and it runs with minimal functionality, and then suddenly, for example, say a printer comes along and registers a printer service. And bundle B didn't really have a printer service, but it was waiting for one, so it was registering to be notified as soon as the service comes along that implements this. And then now that the service shows up, it can actually go and get the service. Now the problem is when we stop bundle A, then we must notify bundle B that the service is going away. And the bundle B receives the event which says the service A is unregistering. And then bundle B can actually give up the reference, so it doesn't unget on the service and it doesn't have a reference in bundle A anymore. Be uninstalled and go away, which causes an event telling everybody that it's gone. Yeah, that's another example with publisher. I don't want to go too much into details. How do we find a service? So we have seen talking a lot about using services. How do we find them? Well, as I said, we have an LDAP syntax to look them up. We have search properties on a service, which typically include the interface, the Java interface, as a package name. And the filter syntax allows, well, fairly complex expressions based on and, or not, less, greater. We even have an approximate, which does a sort of a lexical comparison